So we're asked to find the length of this curve. So I pull up the arc length formula for us here. I think this, oh no, this is Paul's online notes. Our textbook looks like this. They're both the same thing. That classic website, Paul's online notes, they just use different notation. But okay, there's arc length. I think WebAssign's just going to walk us through it step by step, though. Question is this 10? Yeah. They asked us to first find the derivative. Where's sorry, I was looking only at this stuff. This is the original function. So derivative of f of x, the 3 comes down, gets reduced by 1, so that's x squared over 2. Just double checking. Yeah. And then this one, that's 1/2 times x to the negative first in my mind. So when I take a derivative, the negative 1 comes down, and then it gets reduced by 1. So the negative 1 came down, and then the power gets reduced by 1 to be x to the negative second. Because again, this is an x to the negative first power. It's 1/2 x to the negative first. The negative 1 came down, and then the power got reduced. So instead of x to the negative second, I'm going to put it in the denominator. And so this is continuous on this interval. X equals 0 would make it not continuous, but that's not in that interval that we're giving. Okay. It's tough to know. It's like the calculus is something that's a bit challenging, but it's tough to know what WebAssign wants here. Okay, they plugged in that derivative that we just got. Excuse me. What did they do next? What the heck did they do? They factored out 1/4 from everything, which is fine, because if you were to distribute this, 1/4 times 4 makes 1. 1/4 times this, because it's squared, 1/2 is being squared, so that was already a 1/4 in here. And then what do they do next? What do they want us to type? I'm not sure. You could factor out that square root of 1/4. You're left with 4 plus, oh, okay, so they multiplied this parentheses to itself. They did the squaring operation. So if you square that, that means you're multiplying the parentheses times itself. So that's x to the 4th. And then this times this makes 1. This times this also makes 1. And then this times this makes positive 1 over x to the 4th. So I don't know which one they would want. The fully simplified one, I'll try it fully simplified, because when you multiply that parentheses to itself, you get x to the 4th, which they already typed, minus 2 plus 1 over x to the 4th. Okay, and then I guess here they just want us to combine like terms. You get 4 plus negative 2, so that makes 2. And then we still need that 1 over x to the 4th. It looks like they must have factored. They got x squared somehow? I don't know. What in the world? How do we go from that to that? Maybe I made a mistake. I gotta pause. Okay, it's tough, but I did figure it out. This can be factored, and they gave us a clue. It's got to be x squared for the first term. Now we just got to figure out what the second term has to be. And for the second term to be anything, well, it's gonna be squared when we factor it, so they have to be the same. So that's another big hint. The parentheses being squared, each parentheses has to start with an x squared because it's something times itself. That's what squaring does for us. And then we need the last two terms to multiply it to be 1 over x to the 4th. So that means if they're going to be the same thing, it has to be 1 over x squared. And now if you multiply this out, you'll see it turns back into this expression. But what they're missing here is 1 over x squared. And so if you evaluate the square root there, that's 1/2. Square root of something squared cancels out. Okay, I think that's what they're looking for. Still loading on my screen. Okay, that's what they were looking for. And now we can finally do the arc length formula. So the derivative is supposed to go inside the parentheses. Oh, and they've already just simplified it for us because you're taking the square root of something that's squared. And so we can go term by term here. I'll write this out. So we can factor out that 1/2 when we evaluate the antiderivative. Yeah, I think that's fine. I'm going to do it over here though. So the antiderivative of x squared is x to the third over 3. And then the antiderivative of 1 over x squared, that's x to the negative second. When you take an antiderivative, the power goes up by 1. We need to also make sure we get the same result if we were to take a derivative. So that's the antiderivative of this term. You can check because the derivative would turn back into this. So that's what they want here. They want 1/2 x to the third over 3 minus, that's 1 over x. That's the same thing as x to the negative first. And then they just want us to evaluate that limit from there. So you plug in 6. And then subtract what happens when you plug in 5. Let me see if they'll let us do decimal approximation. Note, when you compute the limits of integration, you got to keep it as a fraction. Don't use a decimal approximation.